Okay, so we're in a situation with a car with a driving force of the car moving at a speed of velocity of v. This is the resistance to it, and the weight is 1400 g, or the mass is 1400. Now we know the power is the driving force times the velocity it's going at the time. So we know that, and what we're interested in. Find acceleration when v is 16. So 20,000 over 16 will equal the driving force. 20,000 over 16, we'll leave it as that. So now we're going to do F equals ma. The driving force, which is 20,000 over 16. Take away the 120. Take away the 2 times 16 squared. Equals mass times acceleration. And that gives us A is 0.441 equals A. Okay, now we're going to go downhill. We're going to go on a similar, but we're just going to tilt the page. So we've got a similar scenario. Driving force. Still 120 plus 2v squared. This time we've got a weight component, which is not all normal to the plane. So here we got 1400 g. So now we've got a component of the weight, which is moving it forwards 6 degrees. Same as this one here is 6 degrees. Okay, and we are show the driver at 20 meters per second. So again, P equals dv, 20,000 over 20 equals d. So this time 1,000 is the driving force. So we've got force down the slope is 1,000 plus 1,400 g sine 6. Take away 120 and take away 2 times 20 squared. Okay, equals mass times acceleration. Okay, so that gives us 1514 equals 1400 A. So here clearly we've got A being greater than 0. 1514 over 1400. So therefore it's increasing speed. So to maintain speed, he will need to apply the brakes. Okay, this is a little bit odd question, because I feel there's a driving force here, so clearly the engine's working and the engine's pushing him forwards with a force of 1,000, and to overcome that he's going to put the brakes on. But this is only because you're told at the beginning that the engine's working at a constant rate of 20,000 joules. Sorry, not joules. 20,000 Newton meters per second. If the engine was switched off, we wouldn't have this scenario. But if the engine was switched off, you'll still find that this is greater than this, so you'd still need to brake. Right, now the next part, last part, driver places a car in neutral. Okay, so now we haven't got any driving force from the car. Okay, so here it's in gear, the car is pushing forwards, he's got a brake to stop that. Clearly it would make more sense to put it into neutral, which we're doing for part C. And we're trying to find the maximum, no driving force and no braking force. Okay, so we're trying to find the maximum here. So now we've got part C, 1400 G sine 6, take away the 120, take away the 2v squared equals mass times acceleration. So maximum speed implies A equals 0. So we've got, we rearrange that to make that 0. So make that 0. We end up with v squared is 1400 G sine 6. Take off 120. Because we've got 1v squared, we divide it by 2. So giving v squared equals 657. And v is 25.6 to 366. So maximum speed.